Now let's check geometry. Geometry actually follow the story here. Number of failures before the first success in a sequence of independent Bernoulli trials with the common parameter P. Alright, so this story has been revealed when we have the discussion for the Bernoulli distribution function. So, how to have the PDF if we have the given story? It says, oh, okay, unsuccess is actually we have number of unsuccess is S, and finally it's success. So we have this corresponding probability. But let me change the story to number of failures plus the success. So if so, then we have 1 minus P and raised power to x minus 1 because we still need to have these to indicate the number of failure plus their success. So this is the difference. Current version and a different version. Alright, so this is a PMF. Actually, you can derive CDF, but I skip them. And so that we have a parameter P, and the range actually from 0 to the other. Why 0? And actually, we have 0 failure to have the first success, so starting from 0. But how about this? Actually, should be 1, because at least 1 success, so it can be 1 only, not 0. And the mean follow the current distribution. You can have the results through the expectation, and likewise variance and mode. All right, and actually because we have the results mean, so we rearrange it so that we can have the summarize the formula, and so that the formula we can use the expected number, and we have the results. Alright, so this is the geometry. Actually, we have 2 different versions of geometry. And the current version, we include number of failures only. It won't be necessary to include the number of success. About comments, first of all, this one. This is the story. And second one, geometry and negative binomial. In fact, in our supplement 4, we have this property. Geometry actually is a special case of negative binomial. So the property should the parameter should be 1 and P. So right now we have 1, 1, and 1. So we have binomial. So binomial forms binomial. So we have a number of parameters, sum of the parameters. So of course, it's S and P. So this is negative binomial. And geometry actually it's the discrete analog of or analogy of the exponential distribution. So that it's the only discrete distribution with the memory property. Alright, so you can check the previous requirement for the memory property. And actually, geometry is a special case of a negative binomial. So I apply this one and also apply the property of a negative binomial so that I can achieve the results in comment 2. Well, you see, geometry actually is the discretized exponential distribution, right? So all these. And next one, we want to discuss the negative binomial. And so that we know, oh, okay, geometry is a special case. But a negative binomial actually is the extension from first success to S success. And count the number of failures, or number of failure plus the success. So number of failure before S success, and then we will have the negative binomial for the current one. Alright, so S is the number of failures, so plus success. Alright, so we have the total number. Failures plus success. So look at this. We have this result. Oh, okay. We have X success. And the remaining actually it's the unsuccess. So we have all these. Well, but why we have these? Actually, we have X success. But previously, we don't have the determine 1. So that's why we should minus 1. Minus 1, we have X success. X failures. So we just need to arrange, where we have failures. So that's why the combinatorial number should follow this. S plus S minus 1 because the final one is fixed. This one fixed. So it won't be considered within the component here. And the X failure. So that's why we will have the PDF like this. So it's the negative binomial. And this is the current version. And how about the other version? It says, okay, we have S include number of failure and success. The final one is the S success. So same, minus 1. And in between, we have X success. So we can have this. X minus 1. And in between, we have X success. And here we have X success. Alright, and as for the others, actually they are failures. So 1 minus P, we have X minus S. So this is a different version. If we have success plus the number of failures. So this is the second version. And if so, then we should start from S. Alright, start from S. Alright, so for CDF, actually you can pass on the summation to have the result. And we have a parameter S and P. And currently, if we just can include the number of failures, actually we have 0, 1 to the others. Mean and variance, actually we can follow the definition to have the result. As for mode, we can have the differentiation. And MLE, temporarily I skip them. And this is the story. So previously we mentioned this as well. So it's easy. And this one actually tried to talk about the previous story. Minus success, so this is the failure. So of course this is the story to mention how negative binomial related to binomials. And this is the results from our supplement 4. And previously we applied the results. If we have S equal to 1, that says number of failures till the first success, the first. Because only 1, so the first success. Of course, this one is the definition of geometry for sure. And negative binomial this time, not geometry. So we have the different shape. Alright, that's it.